Okay, so this will be 6.2, the unit circle in the trig of real numbers. This will be day 4 video. In day 4 video, I'm going to show you, we're going to do an activity on your 45, 45, 90 degree triangle rules and your 30, 60, 90 triangle rules. So we're going to do an activity first, and then we are going to prove that tangent is equivalent to sine divided by cosine. Okay, so let's get started. The activity. I want you to find the values of the specified trigonometric functions for a 45-degree angle. So what I'm going to ask you to do is basically find, okay, what is the sine of 45 degrees? What is the cosine of 45 degrees? What is the tangent of 45 degrees? In order to do that, you have to remember your 45, 45, 90 degree rules. If you don't remember them, obviously, if their angles, think about this, if that angle is 45 degrees, that means this angle is 45 degrees, so if that side's 1, it's got to mean that that side's 1 as well, right? If the angle is the same, that means the side has to be the same. You could use the Pythagorean theorem to find that the hypotenuse, which is going to be the square root of 2. So 1, 1, root 2, there is your 45, 45, 90 rules. So if I asked you to find the sine of 45 degrees, so think sine of 45 degrees, I know I take opposite over hypotenuse. So if I do opposite over hypotenuse, I get 1 over root 2. I know I have to rationalize that denominator, and therefore I get root 2 over 2. I kind of just put the 30, 60, 90 triangle rules down here for you. If you didn't remember those, chances are you didn't remember them. So I decided to put them there for you. 1, 2, root 3, that's what that is down there. Okay, back up here though. Cosine 45 degrees, now you're going to do adjacent over hypotenuse. After you rationalize that denominator, you're going to get root 2 over 2. Tangent of 45 degrees, now you're going to do the opposite over the adjacent, which is going to be 1 over 1, which is just simply 1. For number 2, I put the 30-degree angle, but I'm also going to add, will you add a second column to that? Will you also add sine of 60, cosine of 60, tangent of 60? Right? If you know that this is 30 degrees right here, I know this one up here is 60 degrees. So I'm going to ask you to find sine, cosine, and tangent for both of those angles. So think sine of 30 degrees, opposite over hypotenuse. That should be pretty easy. Cosine of 30 degrees, now adjacent over hypotenuse. Tangent of 30 degrees, now opposite over adjacent. Rationalize that denominator, and voila, there you go. Okay, now let's do in terms of 60 degrees. Sine is opposite over hypotenuse, so I should get root 3 over 2. Cosine is now adjacent over hypotenuse. Tangent is opposite over adjacent, and I get root 3. Okay, we're going to talk about in class today, or tomorrow, whenever I see you. We're going to talk about these values right here. I think you are going to be absolutely amazed when I show you where these values actually are in the unit circle that we've been talking about. But you'll see, I'll show you that in class, so make sure that we are on point and we're good to go when we get to class. All right, and then the last one, for some reason it kept disappearing on my screen, so I decided, screw it, I'm just going to write it. So I wanted you to prove that the tangent was actually equivalent to the sine over the cosine. So here's what I want you to think. Tangent is actually opposite over adjacent, right? So I'm trying to prove that tangent is equivalent to opposite over adjacent. Watch this. So I know over here, I know that the sine is opposite over hypotenuse. I know that the cosine is adjacent over hypotenuse. So do you see what I did is I changed this into that's the sine, this is the cosine. Well, I know to solve this, instead of dividing by a fraction, I always multiply by the reciprocal. So here, this turned into multiplying by the reciprocal. What happens? Well, those hypotenuse cancel each other out, and you're left with opposite over adjacent, which is exactly what you wanted. So we just proved that tangent is also equivalent to opposite over adjacent, which is also equivalent to sine over cosine, which is also equivalent to, watch this, I know sine is the y value, cosine is the x value. It's also equivalent to y over x. Okay, so we'll talk about the activity when we get to class. Any questions, comments, concerns, you let me know, and good job.